So, welcome to Unit 3 with energy, and I was recording this video at first, and then I realized that I started explaining energy without explaining what work was, so okay, we're gonna start again. So, work. So, work is basically when you exert a force through a displacement, and like it being through a displacement is very important. So, basically, if an object was at the position x equals 0, and then you move it around, and then eventually you return the object to x equals 0, you've done no work on that object because your displacement is 0. So basically the same logic as displacement, and it's something that you should remember. Anyway, work is also the change of energy of a system, and we're going to go over energy in just a moment. One of the equations is work equals change in energy, and once we dive into the different types of energies, you can expand this equation. We also have units is joules, which are also kilograms times meters squared over seconds squared. And then if the force is constant, if it's the same number throughout, we have an equation where work equals F times, I believe that's the change of x times cosine theta. And then if work is negative, you are subtracting energy from the system, and if work is positive, you are adding energy. Now, let's look into what energy is in a physics context. So, energy is the ability to do work. And that's the only definition you really need to know. There are two types of energies: mechanical energy and non-mechanical energy. We will entirely be handling mechanical energy, but I just put non-mechanical energy here just so you guys know that there are more energy types out there. But the two main types of mechanical energy are kinetic energy, so energy associated with motion. So if an object is moving, then therefore it has kinetic energy. And we also have potential energy, so energy associated with the configuration of a system, which is location-based. So let's say that something raises an object 5 meters above the earth. I physically cannot do that without a really big stool or something. But this object now has gravitational potential energy, which we will go over later. So it has the potential to fall. But we'll go over potential energy in a future video. And then this also includes spring energy, energy in springs, which also has its own section, so don't worry about that just yet. And then for non-mechanical energy, we have things like thermal energy, which is basically heat, light, sound, nuclear, chemical. I'm not going to go into detail about that. But I think that's about it. Also, I haven't put it on the slide yet, but energy is conserved. And I'll go into more detail about it when we do energy calculations. That basically means the final energy is going to be equal to initial energy. Anyways, this video is too long, so I'll see you guys next time.